This video will begin our discussion of radiative heat transfer. We'll begin with basic concepts that overlap some of the material that is typically covered in a Physics 3 course. Of course, we have the speed of light, c0 equals 2.99 times 10 to the 8 meters per second. This is the speed of light in vacuum. And then we'll also have the definition of lambda, which is the wavelength of an electromagnetic wave, given in meters, and nu, which is the frequency of an electromagnetic wave given in cycles per second. These two quantities are related by the expression on the left, where lambda equals c over nu. In this expression, the speed of light is not given with the naught value because we allow the possibility of propagation of electromagnetic wave through a medium such as a solid, in the case of glass, or some type of gas, i.e. the atmosphere. So in that case, if the speed of light varies, then the wavelength of the electromagnetic wave will also vary as given by that expression. However, unlike the wavelength and the speed of propagation, the frequency of an electromagnetic wave depends only on the source. It is independent of the medium through which the wave travels. Quantum theory also introduced the concept of the wave-particle duality for electromagnetic radiation. In this expression, E is the energy of a photon of frequency nu, which is equal to h times nu, where h is Planck's constant. Over here on the right, we have a figure that breaks out the bands of electromagnetic radiation by their typical names: radio waves, microwaves, X-rays, etc. The figure is listed in terms of wavelength, and the wavelength unit is microns, where 1 micron is equal to 10 to the minus 6 meters. It's also interesting to note that the wavelength of an electromagnetic wave can vary over 20 orders of magnitude, from 10 to the 10th up at the extreme high end of radio and TV waves, down to 10 to the minus 9th in the range of cosmic rays. Now, as the wavelength decreases, by virtue of this expression, the frequency will increase, and as the frequency increases, so does the energy of the photon. That is why down here at the lower end of the wavelength spectrum, we find X-rays, gamma rays, and cosmic rays. All of these have high energy photons, and this is the reason why this type of electromagnetic radiation can be so harmful.